Hello there. This video is CCBY-NC. Today we're going to be talking about special right triangles. There are two of them specifically, what we call a 30-60-90 special right triangle and a 45-45 degree, 90-degree triangle. Now, the original ones look like this. We have ours a little souped up. The side opposite the 30 degree is our x, and actually, more often than not, we just make that a 1. The hypotenuse is always going to be double whatever's there. Is opposite the 60 degree is always going to be the square root of 3 times whatever's there. So this is our original one that we use sort of with the unit circle and so on. The other one is, of course, are not drawn to scale because they're hand drawn. And this is a 45 degree, which implies that this is also 45 degrees. And our typical one is a unit, 1 and 1. So these two are always the same, opposite the 45 degree. And this one is always, in this case, x is 1 times the square root of 2. So again, I tend to use these a little bit more, but we're going to use these in a special way this time. Let's start with our first example here. And here we have a 45-45-90. So even though they didn't write the 45 there, we know that there's a 45 there. And this 16 here is the hypotenuse, which means the 16 is equal to x root 2. Well, what does that mean for us? Well, we're going to solve for x now, because we're going to find the missing sides. And this is going to become x equals 16 over root 2. If we rationalize that, we get 16 root 2 over 2, which is just 8 root 2. So that's x. And if you remember, x is the length of the two legs that make up the right angle. So that makes this 8 root 2, and this side also 8 root 2. Let's move on to number 2 here. Here we have a 30-60-90. Now, even though they didn't put the 60 there, we know that there's a 60 there. It's again implied. So we know that the opposite, the 60 degree, is our x root 3. So this means that root 6 is equal to x root 3. Once again, I'm going to solve for x. And this gives me, once again, implies that x is root 6 over root 3. And if you remember your radical rules, we can make this one giant radical, which means x is just root 2. So x in this case is the side opposite the 30 degree angle. So this is root 2 here. And that makes our hypotenuse 2 times that. So that makes this side 2 root 2. Number 3, once again, we have a 30-60-90 triangle. And we have the side opposite the 60 degree again. In this case is going to be 12 is going to equal x root 3. Divide by root 3 again. This implies that x is going to be 12 over root 3. And we're going to rationalize that denominator. Giving us 12 root 3 divided by 3, or 4 root 3. This means that this side here, our x, is the side opposite to 30, which this is our 30 degree angle here. So this is going to be 4 root 3. And once again, our hypotenuse is going to be double that. whatever x is, in this case, we're going to double that. That makes this 8 root 3. A couple more examples. So here we have, it doesn't say what the angle is. However, because it's an isosceles triangle, meaning two of the sides are the same length, this implies that this has to be a 45, 90 triangle. So this is also 45 degrees. Side opposite to 45 degrees is x. So we have that x in this case is 4 root 10. So this side is the same as this one, 4 root 10. For the hypotenuse here is going to be x times root 2. So x times root 2, 4 root 10 times root 2. Now this gives us 4 root 20, and 20 is 4 times 5, so I can actually pull 2 root 5 there, which gives us 8 root 5. So once again, this is 4 root 10. This one down here is also 4 root 10. That makes this one 8 root 5. And we have one last example. Of these triangles, and we have one more here. So here, once again, we have a 45, 45, 90 triangle. I know that because the two legs that make up the right angle are the same length. We have, again, an isosceles triangle. So we have that the hypotenuse in this case is 5 root 2. If I go to my triangle here, the hypotenuse is going to be whatever x, I'm sorry, this is the hypotenuse. This is going to be equal to x times root 2. And you can see those root 2s are going to divide out. Making each of the sides a length of 5. So this is a length of 5, and this one is also going to be a length of 5. All right, we're going to use the same logic for our last example here. We have a square window that has a diagonal of 6 feet. So we have a diagonal of a square window, which most windows are not square. Well, you'll pardon the bad writing. We have a diagonal of 6 feet. Now, I want to make it clear that makes, because it's a square, these two sides are the same, which means we now have a 45, 45, 90 degree triangle. And if our hypotenuse is 6 feet, if we go back up to our triangle here, our hypotenuse is x times root 2. Which means x is 6 over root 2. And if we rationalize that, and here's our exact answer. And you'll notice in the problem, it says round your answer to the nearest hundredth. So we're actually going to use a calculator here. And it's actually asking for the height of the window. So they want this length here, and that is going to be 3 root 2. With the decimal approximation here. 3 times the square root of 2. So that's going to be about 4.24 feet. Thanks.